So that gets toward infinity. It goes 0, so it just becomes.
Right. And hence, that sum is equal to 1. Does that make sense to you?
So what's the last part? Like, so our answer is a limit to 1?
Yeah, because as n goes to infinity, 1/2 to the n goes to 0.
Right.
So you 1 minus 0. Yeah, go ahead, Christian.
Does that if-then statement go both directions for the above?
No. No, it does not, which is unfortunate. And I'm glad you're bringing that up, because that whole if-then doesn't go the other direction is going to play such a central role to all the theorems we talk about, because some do and some don't. And knowing the difference of when you can run it in reverse makes a huge, huge impact on evaluating these things. All right, let's try another one. Maybe one that's a little more
So,
sophisticated.
if I was to take Miles's class, would you be in there to watch this amusement?
You'd be sitting
Well,
in the
if
back of the class
if
eating
it
popcorn.
was not at the time he was working, he would
Yeah, I
probably
think
come
I
in and
would.
sit.
I think I'd go observe his class for the fun of it. I think
I
your
could
head
totally
might
see you doing
explode,
that.
Luciano. You know, I'm playing around. You probably shouldn't do it, because you'd probably be very frustrated in the end, and just, yeah. But that's why I brought it up.
He's the complete opposite of Dr. Schulteis.
Huh?
The complete opposite of Dr. Schulteis. Dr. Schulteis is always on time, always go, go, go. Dr. Miles is very relaxed, very, let's just chat for a while. We'll get to the math
Is
at
it
the
10
end.
yet?
Mm-hmm.
Really?
I think so.
Yeah. Okay.
Luciano's like, crap, I can't get him fired.
He's amazing.
That was his face. He was like, oh.
I don't think Schulteis is tenured.
Can't you get, like, professors, like, on tenure, can't you, like, if they write a bad enough evaluation, can they lose tenure?
Eventually. I mean, it has to be like illegal.
Yeah.
Yeah.
I mean, it has to be legal, because there's legal binding agreements for tenure, and I don't think this. No. I mean, the short answer is no. You really have to screw up, like, you have to be like sleeping with a student, I think, to really, really, really screw it up, you get so much leeway and slack with it. And out here, actually, more so than other institutions are a little more, like, even like MIT now, even if you get tenure, if you don't continue to publish, you can get stripped of tenure. But out here, if you get tenure, if you don't publish, you just can't get promoted to the next rank. You never lose tenure. So, all right, guys, let's try this one.
Sure. So you
Now,
start at 2.
We start. So it started 2, just like last time. I only started 1, but I did change it. I put a 2 up in the numerator instead of naught, just so that we get some reasonable partial fraction decomposition. And that's actually the short answer here. Is when you evaluate the sequence of partial sums here, it is easier to do it in terms of a partial fraction decomposition than not. Let me illustrate why that is.
So there'd be 2/3.
Well, so remember, n is starting at 2, right?
So you'd have 2/4 minus 1.
Okay. So here we have our s sub 1. And we're going to have an index shift, because even though n is starting from 2, it's still the first partial sum. A little bit confusing, because our first partial sum is going to be n equals 2. But we can start with s sub 2 if you want. It's not going to matter, because we construct the s sub n anyway. But yeah, this is just going to be 2/3.
2/8.
Right, and then go ahead and combine them up. So let's see, we get this together, we'll make it up to 24, let's say.
Is it easier to simplify?
Yeah, probably is. Plus the next term, right, that's going to be the 4, so 2/15. Let's see, denominator between 12 and 15?
20.
60. 60.
Oh.
Yeah.
Oh, but then it simplifies.
I'm with you on 60. Now we can continue with this process, but this is what Christian was saying earlier. Because sometimes you get the elements of a sequence, and do you see a simple discernible pattern in going from 2/3 to 11/12 to 63/60ths?
No.
Not really. It's not to say there isn't one out there, right? But it could be some complicated rational kind of function like we saw earlier. So it isn't always possible just to look at that sequence and do some pattern matching. The 1/2 to the end was simple, right? So we could actually see that play out. So in a case like this, and this is also why I said this whole idea of finding the sum by establishing the limit of the partial sums, while technically the theorem holds true for all series, the difficulty in establishing the S sub n makes it applicable to a very, very small class of series. Basically stuff like 1/2 to the n and stuff that you can decompose with a partial fraction. That's really what it's limited to. So instead of doing this, I'll just make a comment. Just based on the difficulty of the construction of the nth partial sum, let's back out and try something else. So what I'm going to do here is first work on a partial fraction for the 2/n² minus 1.
It'd probably be easier to see a pattern if you converted them to 60ths, the first and second S.
Yeah, but then you'd want to convert them to something else when you go to the next term.
Mhm.
And that's the trick, because how do you know what base is good for the nth term? Right, that's where so again, Christian, it's not impossible, right? It's just not a pleasant thing to have to sit down and do. So there are better ways to approach it. Okay, so what we're getting out of this, let's see here, A is negative, so I'm getting that.
So can you split that up?
Actually, not necessarily. And I'm not going to split it up in this case. Sometimes you can't, we'll talk about when you can split it up, when you can distribute that sum through. But what I'm going to do is just start evaluating this starting from 2. That is, what I'd like to do is represent the nth partial sum, just by listing out the elements of the sum that I'm adding up. So, for instance, when n is 2, you see you're going to get 1, and I'll even put the parentheses in here, 1 minus 1/3. That's the first term. Is everybody with me on that? Jessica, you okay with that?
Mhm.
Then, of course, since it's a sum, right, I'm going to add to that in the next term. So when n is 3, I'm going to get 1/2 minus 1/4. When n is 4,